Section 6.3, normal distribution, bell curve. We're your hosts, Mr. Craig and
Mr. Nelson.
Miss Johnson can't be here because, well, we'll talk about it later. Anyway, go ahead, Mr. Nelson. Show us how it's done.
All right, so when we get into normal distribution and bell curves, we're actually talking about how data can be spread out across an x-axis, if you will. Data can be spread out in many ways. Here we have three just different examples. It could be skewed left, maybe it's skewed right, or maybe it's just not skewed at all and it's kind of all over the place. I mean, we still have unimodal, maybe bimodal here. But basically here we're talking about many ways that data can be spread out. So this definitely could be bimodal. Maybe you might argue that this one's slightly lower, so maybe it's unimodal, but we can still describe the data. However, we want to talk about more in depth about what normal distribution or the bell curve looks like.
So what we're talking about is those cases where data is not skewed. And so when data is not skewed, you get something called a bell curve. This happens with normal distribution. Now, I want you to realize that if you look carefully at this graph, you'll notice that this is slightly higher than that, and this is slightly higher than that. So you don't have to be exactly symmetrical in order to be considered a bell curve or to be a normal distribution. You just have to have a basic symmetry. And what that does is it causes the data to break into basically two halves, right? A left and a right. There's no bias. It's basically evenly distributed. Normal distributions happen pretty much all the time in nature. If we're talking about the average age of people, this is, a lifespan might be average age here. Some people live a little bit longer, some people a little bit less. Some people get hit by a car, die early in life. Some people live to 120. A normal distribution can be anything that happens in nature or in reality. If we talk about maybe a test, most people are going to be average on the test. Some people are going to do slightly better. Some people are going to do really well, and some people are going to be slightly worse. Now you say, well, what about if you're in an honors class? Okay, so in an honors class, sure, people might do better on a test. We'd still get a curve. It would just be slightly skewed to the right, right? You'd still have people who do really good on the test, and some people do a little bit less. But in average, you'd see that our mean, our median, our mode kind of go up because as a whole, the class does better. But still, the standard deviation happens. Or I should say the normal distribution happens. We'll talk about standard deviation later. All right, moving on. What does that do to our data, Mr. Nelson, if we have a normal distribution?
So when we have normal distribution, you have these three properties, and we're going to explain what that means. So when we have the normal distribution, we can already tell that the mode is right here because the mode's the most, right?
Mean is ACD.
Mean is ACD. But also, because of the normal distribution, the median is also right there in the center. So we have our mode and our median right there in the center of our data. But because it's normal distribution, the average or the mean is also somewhere right there in the center. So what we end up having is that the mean, the median, and the mode are all going to be basically the same. They might be off a little bit from each other, but they're all going to be basically the same.
Mama. No, wait a second. Yes.
So also the property number 2 here that we have is a symmetry about the center. Remember, the median cuts data directly in half where you have 50% of the data above and below. And because the median and the mean and the mode are all in the center, that's exactly what we have. 50% of the data is going to be above the center and below the center. And that leads us to our third property. And also a reason why our data is going to be symmetric here.
So normal distribution simply just means that we have the mean, median, and the mode are about the same. And things go from there. So what happens then if a normal distribution happens like so? That means our mean, median, and mode are about the same, right? So if we look at a piece of data, as soon as we see that it has a normal distribution, we go, okay, our mean, median, and mode should be about the same. But what happens if we're taking a test and we have to account for Miss Johnson, who scored really poorly on the test, and she kind of brought the class average down? We still have a standard or a normal distribution, but it's kind of skewed to the left.
It's skewed to where the outliers are, or in this case, Miss Johnson's test score. But most of the class is doing pretty good. That's where most of our data is right here. So we still have a mode at the highest point. So what are these other two data points? Well, one of those is the median. One of those is the mean. So which one's which? We've talked about this in class before. Miss Johnson is probably actually taking the average score down, where the median actually might be the same as the mode, but the median may or may not be affected even by just one outlier. However, if you throw a couple more people in there with zeros, it might bring the median down, but it definitely will bring the mean down. So what we have here is the mean getting affected the most by these outliers over here. The median not so much affected by it, and the mode sitting up there still as being the most occurring score.
So what you're saying is that, like, the side that's skewed pulls the mean towards it? Is that what you're saying?
Absolutely, Mr. Craig.
Wow, I'm smart. Because look, what if Mr. Craig took the test? And obviously, I'm perfect. Duh.
Yeah.
So I skewed the data to the right. So again, mode isn't affected by that because mode's the most, so I should be right there. But which one of these do you think would be the mean? Well, again, because in this case, because we're skewed right, and Mr. Craig is so perfect, that's right, I said that, is so perfect, he pulls the data off, and the mean gets brought up. This is one of the reasons why we said median is sometimes used when data is skewed, because it's less pulled off. Some would argue, why don't we use the mode? Well, because while the mode is most often in the middle, there can be weird cases where the average or the median isn't the one that's most often happening on the test or happening in a class. It happens rarely. So we usually stick with these two, the median or the mode. I mean, excuse me, the median or the mean. But we still want to show mode because it shows the same. Okay, so which brings us to a data. So if you look at this for a second, you're like, okay, I see it has two giant hills, and one says women and one says men. And I tell you that this is about height. And so what do you think the first thing people say when they look at this graph?
Women are taller.
Well, obviously, right? Because this normal distribution is much higher than this normal distribution. That is a common mistake people make. When you're looking at data or graphs, you need to make sure you're looking at what's going on here. On the side here, it says number of people. When we did histograms, we called this the frequency. On the bottom, though, it's reading from left to right, and it's saying the height in centimeters. And so if you look at it that way, you'll notice that the women height is somewhere around there, and the men's height is somewhere around here. Now, Mr. Nelson can show you this clearly when we talk about box plots. If we overlay this with box plots.
Yep. So we're going to throw a box plot up here. A box plot's really easy to see the median with, because the box plot has the median right there through the center, right?
Because Mr. Craig can't draw a straight line.
And with normal distribution, the mean, median, and the mode all happen around the same area. And so we actually just drew a box plot up here really quick to show that. And that median happens around 161, 162 centimeters. So what we're saying is the average or the middle height for women is about 162 centimeters, whereas for the men,
man, Mr. Craig, you can't draw a straight line. I guess I'm not perfect. All right, the median for the men was about 175, maybe 176. But we also noticed that that interquartile range, or that 50% of the data, tends to spread us out a little bit more, so there's more range here. So again, one of the biggest mistakes people make when they're reading graphs is they say, well, taller is better. It's like the little kid, you give them a tall glass. If the other one is big and round, and the other one is skinny and long, little kids say, oh, well, this one's taller, so it must have more liquid in it. But this one has more volume. And so it's about reading your graph correctly. And so when we look at this graph, at first look, we say this is taller, but when we read it more carefully, we realize that what we're measuring is height, and it's being measured on the x-axis, and this is showing that men tend to be taller. Now, it doesn't say that women can't be tall. And it doesn't mean that men can't be short. But on average, and this is where we come back to that bell curve, the normal distribution, most people tend to be within this range. So while there's always an exception, most people fall within that range. All right, that ends this part of the video. We're going to come back and talk about standard deviation.